Welcome back, everybody, to another video lecture from Mrs. Semino. Today we're going to be talking about scientific measurement in chemistry. And in this lesson, we're going to see four different topics. We're going to see accuracy and precision. We're going to get some definitions and understand what they mean. We're going to figure out what an estimated digit is and how to use estimated digits. And then in the next video, we'll talk about significant figures and calculations using these significant figures. So our learning goals for this unit are to figure out why using significant figures is important in science, to define a significant figure. We're also going to practice how to round to the correct number of significant figures because you're going to have to do that in a lot of your problems throughout the school year. And then, of course, we're going to be making these calculations and then, of course, getting our answer in the correct number of sig figs. So while this might kind of seem ambiguous right now, like when are we going to use this? As soon as we start getting into our math chapters, this unit will be super helpful. So on this slide, we're just going to go ahead and talk about some definitions. And the two definitions are going to be for accuracy and precision. So think to yourself right now, what do those words mean to you? So you probably have accurate, pretty accurate. So it describes how close your measurement is to the true or accepted value. Precision, on the other hand, this one's always a little bit trickier. This describes how repeatable your measurements are. So let's talk about the difference between these two. So now let's start off with a dartboard. So you guys have probably seen a dartboard before. It's got these little circles here. It has what we have a bullseye in the middle here. And then if I was to throw darts and they were to land, okay, and they touch the bullseye, I would say that my darts in this case were accurate, but notice how they landed in different spots, so they weren't like grouped closely together. So we'd say that that is an accurate, or my three dots or darts that I threw them very accurately. On the other hand, if I had a bullseye, another dartboard, let me say, with a bullseye here, and I threw three more darts, and I hope you can see that they're all up here in this corner there, I would say that these were very precise, but they were not accurate. And they're precise because they're grouped really closely together, but they're not accurate because they didn't hit the bullseye. So in science, we want to be both accurate and precise. If you need a little bit more information on that, I love this little video here, so go ahead, just grab this link and go ahead and watch it on YouTube. One of our objectives was to figure out why significant figures are important. So we're going to go ahead and do that right now. They're important because they let others know how precise your measurements are given the tool or equipment you are using. So when we talk about the precision of an instrument or a tool, we talk about the number of tick marks, or if you want to think of like decimal places that it can go to. So some tools will go to the meter, like the meter stick, but then if you look at the meter stick, it can even be more, you get more precise measurements because there's centimeters, and then even more precise because there's more tick marks for millimeters. But that's as precise as we can get with that meter stick is the millimeters. So the idea here is if a student gave you a measurement of 0.000002 millimeters using a ruler, you should not trust their measurement because, just like I was mentioning, that classroom ruler only measures to millimeters, which is really like 10 to the negative third. And I don't know if you can see here, but this would be 10 to the negative 1, 2, 3, 4, 5, 6. So you'd need a much more precise measurement device to get this measurement. So you just want to say how precise your measurements are, and then the more precise you are, the more accurate you can be. Significant figures also help identify the precision of that measurement tool. We kind of talked about this on the last slide. So they'll tell you the number of tick marks that tool has, or the smallest place value that that device will measure to. And then significant figures will include the last place value the device measures to, and then this thing called an estimated digit. And we'll see what an estimated digit is on the next slide. So let's talk about what an estimated digit is. So we have two rulers here. You can see this just goes to the ones place. And then if you were to count, you'd see that there's like 10 tick marks in between. So this is going to go to the tenths place. And this teal string here is the same length, okay? But what might happen is when we measure the same string using two different devices, we're going to get slightly different measurements, okay? So let's pay attention to this because kids seem to mess this up. So this is something you really want to pay attention to. So when we look here, it goes to the ones place. What's one place value smaller than the ones place would be the tenths place. So the 3 is in the ones place and the 4 would be in that tenths place. So if you and I were to write down two measurements, I might write 3.4 and then you might write 3.5, okay? And the idea here is either one of these measurements is better than saying 3 or better than saying 4. Because does this teal string stop at 3? Nope. Does it make it all the way to 4? So by using our estimated digit, that would be the ones place, the one place value smaller, the tenths place, that actually makes our measurement more accurate, but it also makes it more precise. Because if I had just said 3, okay, or 4, do you see how, like, if we were to subtract this, there'd be a difference of like a 1? On the other hand, if I do the difference between these two numbers, it's a difference of 0.1. So this one is the more precise. This gives us a more precise measurement here. And then if we have even more tick marks, and again, I said the tick marks went to the tenths place, so we would be certain of this value, but this one would be our estimated digit. Again, even though our measurements might be slightly different from each other, if you were to look at the difference between these two, it's between 0.02. So that's even a more precise measurement that we're getting there. So just to review, you want to use an estimated digit. And an estimated digit is a value that, I want to put this in quotation marks, that you're going to guess based off of the ruler or the device that you have. And so that estimated digit is going to be one place value smaller. So the 4 is our estimated digit here. The 2 is our estimated digit here. Then the device provides, but that helps make our measurements more precise. And like I said up here, it would be better to describe this as 3.4 than 3 or 4. So it's also making our measurements more accurate. So like I said, if we know the measurement, we can predict what place value that device went to. So when we look at this number here, 19.1, so look at it, what would the estimated digit be? I'm hoping that you're saying that the 1 would be the estimated digit. So I know that the device went to the ones place. So if we were looking at tick marks, this would be like 1, 2, 3. When I look at this one here, again, that last digit is still going to be your estimated digit, but what we know is that this one went to the tenths place for its tick marks. So between each of its measurements, it had 10. Okay, I'm not going to be able to squish 10 in there, but this one went to the tenths place. And then this one kids kind of always are like, oh no, I don't get this one. So if you're having a hard time with this one, it's okay. So in this case, the 3 would be our estimated digit, and that means that our device actually went to the tens place. So the way this one would work would be 0, 10, 20, let me put another little line here, 30, is that our device would have measured to about here. And so saying 23 is going to be better than saying 20 or 30. So I'm hoping this is making sense, and we'll do some more practice in class.